In this little video, I'm gonna talk about prototyping. I have a couple of prototype boards I want to show and demonstrate here, and you see one board here on the left hand side and a couple of smaller boards on the right hand side. So let's start with the big one. The big one here is the same size as 6 of the small white chips, so 3 by 2, and I will show a picture at the end how it fits with the other boards. So how does it work? In the middle here we have like a number of holes. They're all 0.1 inch in distance, or 2.54 millimeter for those who's into metric. And they're connected like the red line shows here. I haven't drawn all the way across. On the top and the bottom, you also see the ground and VCC, SDA and SCL and so on, which is the main signals we're using. And then to the side, you see like the rest of the connections. So there's resource with typical 5 volts. There's an IO pin. There's a receive and transmit on the serial port. So that's how they're connected. So the idea is you plunk something in the middle, use some of the surrounding holes to connect to some of the bigger buses. So either the 4 long ones where you get power and I2C, or some in the side if you have something special that, for example, uses serial connection. Then let's go to the smaller ones. There are some of those that we provide with the kits, and they're kind of like a little bit more easy to get to. So before I go ahead, I just want to show the core that is going to fly with the chips here. So this is what we call the extended core. So on the bottom you can see there is an extended core. It's 3 chips long and 1 high, and it has the same processor as you see on the back of the processor you normally use. The middle slot is a camera input, then there's a room for an SD card, and then there's this extension port that you can see is being used on the second one here, where I have plugged one of the prototype boards in. This port is normally used for lower radio, but when we fly on the bluShift mission, we're not going to use the radio. So there's room for doing some prototyping and use that port for that prototype. Here's the board that I'm talking about first, the one you saw that was plugged in. So this is the simplest of them all. This is a board where you can put in a couple of sensor resistors. So in this case, it's light dependent resistors, LDR. And you then do a voltage divider where you have the sensor as the one resistor and another known resistor value. And that gives an analog value you then read. There's also a very good way of demonstrating an analog sensor is just giving a number. So the LDR here gives a number between 0 and 4095. We'll see that later in the code. But if you put a, for example, temperature resistor in, well, it will also give the same value. You have to calibrate and figure out what that value means in, for example, lux, or what that value means in Celsius or Fahrenheit, if it was a temperature resistor. But it is the easiest because you simply just have to get a couple of resistors and a couple of temperature resistors, and you can put them in, and the code is going to be straightforward. So here is an example of the code. I found that, I modified it a bit, but I found it like on the link down there. And if you search for LDR and ESP32, which is the core we're using, you'll find a lot of different examples of how that have to look like. So this code is straightforward. You can see on the board itself it says sensor 15 and sensor 33. And that's because I'm referring to the pin numbers on the ESP32. So when you are in the code, you simply just say, well, my light sensor pin 1 is number 23 and number 2 is 15. So you define the 2, and if you're not familiar with the programming here, you soon become that. We have a setup section here where we just open the serial port, and then we have a loop where I'm telling now I want to work with pin 1, so I print that out, and I read the value from pin 1 and I send it straight into my analyze function below. Do the same for pin 2, and my analyze function I simply just print out the value, plus I have a little if-else statement here that kind of like figure out what text I should allocate to what value. Now, that can be very different from sensor to sensor. Again, this is a part of the calibration. You could also put a value in where you say, well, a known so much light is so much lux and so much light is so much lux, and then you can use Arduino have something called a map function where you can then kind of like map the value into your new value. Let's go on to the next one. So the next one is this other green board here. This is a little bit more advanced in the sense that this you typically use if you have like another sensor sensor you bought somewhere. So like Adafruit, SparkFun, Microelectronica, a lot of these different have like these breakout boards as you see on the right hand picture. You see this blue board I've soldered on the top. So middle board here is the one without anything, and the right hand one is the one where I soldered project into it. So I bought this board as it is, this blue board here from Amazon, and this turns out to be a IMU of some sort. I just wanted to kind of like experiment with it and plug it in here. But that could be that you have a sensor that runs either I2C or SPI that you want to use. So the way that works, this board here, is that these holes on the left hand side are connected like the white line shows. So you plunk something in there in the very leftmost holes, and then you connect that to the bus by wiring from the middle row to the rightmost row. So here we're gonna put VCC over, we're gonna put ground down there, gonna put CL and SDA. And if you see on the board next to it, you can see some of the wires underneath the board sticking out there, but you can also see it says VCC, ground, SCL and SDA on the blue board, and that's the ones that connect to the similar signals on the other one. If you go down to the white version, so the green version up here is for the extension port. The white version here is that you have other signals. So in the top one you have SPI and I2C, and the bottom one you have serial and I2C. You have a little bit more pins on the green one, so you have IO 15, 33, and IO 1 is actually transmits the same as the TX on the bottom one. On the bottom one you have an IO pin, but it's only available if you use it with your normal core, not with the extended core. So of course, if you're not using I2C at all, if you're not using any of the other sensors that we provided, then those two pins can also be used as IO pins. The same for RX and TX. Just have to unplug it when you program your device, because that uses those pins to program. But once you programmed it, you can plug them in and use the pins only. So how does that work? Well, it's slightly different here. Those pins are the pins that far apart here, like that. They're connected. So you connect your stuff on the top, and then you have the shorter connection at the bottom, similar to what we did on the board above. So slightly different way that this is put together. And then finally we have this board, and that's just absolutely to demonstrate that you don't have to put it in the top and then solder across. And if you have something that have loose pins or wires like I have here with the LED, I just soldered this thing here to demonstrate that I had some loose wires. I might as well just put them straight into the right pins instead of putting them to the top and then crossing the pins on the bottom. So you can use the board as you want to. Suggest you use a voltmeter to just check which pin are connected to which if you're like in doubt, but that's how it works. And by the way, obviously when you do this prototyping, the standard code that comes with your flight station, have no idea what you're doing, so you need to incorporate that into the code so you can kind of like use that. I will provide some skeleton code, very, very, very simplified skeleton code, but then you have to develop yourself. And if you want to reuse some of the other sensors together with your own project, well, you can either modify the big code which will be made available, or you can use the skeleton code and add your own stuff to it. But using the hardware part here, doing the prototype, that's by far the easiest one. And do maybe find like some library somewhere and test the example code is great. The programming is always the thing that's gonna take a long time. There's many bugs that maybe have to be sorted out, and it can be interference with other boards and other projects and things like that. So make sure you put 90% of your time aside for the programming. And that's about it. Here you can see that I blocked one of these extended cores in with one of the project in the extended port, and then I have the big 2x3x chips on the top. I haven't actually used it for anything yet, but I look forward to see what you guys use it for. In the version next to that is 6 sensors. Actually it's like 5 sensors that we plugged in. The black thing that sits on top is a 45-degree mirror that sits on a light sensor, so the light comes in from the side. And of course the prototype board in the bottom, the green one, have LDR. They should probably not face up but face sideways. They come on long wire, so when you solder them in, you can just make sure they are facing the right way. And you can see up in the top right corner, I took one of the other prototype boards, and you can actually put, if it runs like for example I2C, and you can put many of those in. You can fill your whole board with different kind of sensors that you have built that way. So thank you very much for that.